The section about text summarization. So we are going to learn what is text summarization, and especially we are going to look at two different text summarization. The first is abstractive and the other is extractive. And we are going to learn some metrics. I think last time we learned the metrics for the text analytics with simple metrics like precision, recall. And in this section, I would like to teach you PLEU, rough, and meteor. And we are going to learn some algorithms like frequency-based abstractive summarization. We are going to use the TF-IDF. You already know the TF-IDF, and we are going to learn about text rank. So what is text summarization? So we call summary. So we want to produce a short. Short means long, abridged version. So sometimes we call it abstract of a text. So we want to make it short while retaining the key. So if we have the long text, we want to know what is the keyword or the key or the relevant information. So this is a task useful for creating outline. So outlines means, like this one, we usually put the palette, or abstract tool of any document, article, and etc. We can make summary. So if you do chatting, so there are many chat, or if you have a lot of emails, so we can make summary. Action items from a meeting. So if you join any meeting, there will be a hero or minute of meetings, and usually the meeting notes is very long. We want to just extract what are the action items. Or we want to simplify text by compressing sentences. So the sentence, like this one, if you have many documents, then you can just have a short version, because this is the text summarization. So the input of the text summarization, we can have single document. We call it single document summarization, or SPS. Or we can have multiple document summarization, MDS. The output, it can be single document summarization, SDS, or multiple document summarization. So it depends on what is the input. If the input is single, of course, we can have single. If the input is multiple, you can have single or you can have multiple. And the approach to do this text summarization, it can be supervised, it can be unsupervised. So if it is supervised, it means that we know the reference or we know what is the summary. But if it is unsupervised, we do not know what is the reference. So there are two focus for the text summarization. The first is generic, no condition, unconditioned. And the other is query focus. Query focus means we have some condition. So we put the condition and we can have the result. So let's take a look. In the single document summarization, we have a single document and produce abstract, or we produce outline, or we produce headline. If we have multiple document summarization, even a group of documents, so we have multiple documents and produce series of news stories on the same event. Or we can have set of web pages about some topic or question. So for example, this is a single doc summarization. So we have a very long document, and of course, if you try to understand this one, it takes more time. So you can make the summary. The summary will be short. Okay, we know that this document is about the Cambodian government that rejects opposition call for talks abroad. So this is the summary. Or we can have several documents or multi-document summarization. So this is a document about the flight Malaysia Airline, which crashed and caused some casualties. There are 239 passengers and crew died because of this crash. So this is the first news. This is another news. So this is another news. And this is, let's say, news number 1. This is news number 2. This is news number 3. And we want to make summary from all those documents. So this is the summary from those documents, and we can get a kind of new conclusion or a new information. Instead of the numbers of documents, we can distinguish the output into 2. So the first is extractive summarization, and the other is abstractive summarization. For the extractive summarization, it means we want to select from the source text span that capture the key information. If it is abstractive, then we generate new text that encapsulates the key information from the source text. So what does it mean? Let's say this one. If you look at this figure, you can see that the document contains the yellow color and the blue color. So if you want to summarize this document with the extractive, it means you will just select the key or the relevant information. For example, the blue color. Okay, the blue color is the key. The blue color is the key. The blue color is the key. So we extract only the blue color. So the blue color will be here. When we deal with the abstractive summarization, it means we have a document and we generate a newly text. So this is new. New text, and it is maybe different with the text that you have in the document. So we can see another kind of diagram like this one. Let's say in the document you have sentence 1, sentence 2, sentence 3, sentence 4, sentence 5, and sentence 6. When you do the extractive summarizer, it means you will select what is the key point from this document, and it is based on the sentence. So the summary would be 1 or 2 among the sentence. So in this case, the summary is sentence 2 and sentence 4. So it is 1 among the text. So the sentence 4 is also 1 among the text. But for the abstractive summarizer, you have sentence 1, you have sentence 2, you have sentence 3, you have sentence 4, you have sentence 5, you have sentence 6, and when you do the abstractive summarizer, then it will be a new sentence. So when we do the text summarization, there are two focuses. The first focus is to summarize the content of the document, or we call it generic summarization. So we just do the summary. Or the second, we call it query focus summarization. So generic means just make summary in general. But the query focus, we have condition. We have condition. The condition means, maybe you have question, or maybe you have rule. That's why we call it query. Query means you have some important things that you can ask. So the condition will make the algorithm to summarize the document. So summarize a document with regard to a user's query. So WRT means with regard to. With regard to. Okay. And there will be a complex question answering, such as answer a question by summarizing a document that has the information to construct the answer. So if you, for example, go to ChatGPT, so if you put a document, so when you put a document into the ChatGPT, and the ChatGPT can make the summary of this document. So that's the generic summarization. But when you ask the ChatGPT, for example, show the important message from the document, then this is query, because you have a condition. So the query focus summarization, you can see from the search engine. For example, if you use Google, then you can ask like this one: how long did World War II last? So we can have this document. We can have this document. So this is what we call as the query. So the query focus summarization, we will create answers to complex questions. So complex question, sometimes we can ask like this one: how long did the World War II last? Or maybe you will ask, when did the World War II start? Something that is complex. And then you will again ask, who start the World War II, and so on. So it's a kind of chat. It is also possible with this kind of complex question. So that's the meaning by complex question. Then we can do the summarization from multiple documents. Instead of giving a snippet for each document, so snippet means just a result or an alternative of results, we can create a cohesive answer that combines information from multiple documents. So we have question, we have maybe 1, 2, 3, 4 questions, and then we put into documents. So there are many documents, and after we have many documents, so we can create a comprehensive or a cohesive answers. So there are several answers, and those answers are related. And after we have this cohesive answer, maybe the user will select what is the best answer. So this cohesive answer combines information from multiple documents. So the question is, if we have like this one, does this seem like a job for extractive or abstractive? So yeah, in the text summarization, because we distinguish between extractive and abstractive, but in this kind of things, we can say like it is the combination between the two. So after you extract, you want to make the abstract. So it's like a hybrid mechanism. So when we do with this text summarization, we need to understand some of the metrics. So there are several quantitative metrics to assess the outcomes of this model. Some of the traditional metrics are PLEU, rough, and material. Let's see one by one. Rough, we call it ROUGE. It is stand for recall oriented understudy for Kisting evaluation. So this is the ROUGE and E. Rough measures the precision and recall. So we learn about the precision and recall in the performance of the supervised learning. We will measure the precision and recall of the generated summary with respect to the reference summary. It means we have generated summary, and then we have reference summary, and we want to compare. Generated summary means the result from the text summarization. The reference summary means the ground truth, the label that we have. So we will measure the precision and recall between the generated and the reference using n-gram. And we just measure with the co-occurrence statistics. Specifically, it computes the precision and recall for overlapping n-grams of different lengths, and it can be ranged from unigrams, for example, single words, until the longer sequence of words. So unigram is just one word. You can have bigram. Okay. In the final in the mid exam, you have bigram. You can have trigram, okay, and so on. If the ROUGE score is 1, then it is perfect match. The value can be from 0 until 1. So 0 means it does not match. There are some variants of the ROUGE. We can have the ROUGEN. Okay, let me just call it rough. We have rough N. N means we want to measure the overlap of N grams. So N can be any integer, but mostly it is 1 or 2. So for example, if we call rough 1, it means we want to measure the overlap of unigram 1. If we have rough 2, it means we want to measure the overlap of, sorry, I didn't. The rough 2 means the bigram. Sorry. 2 words. So if rough 2 means 2 words or bigram. If rough 3, then it means trigram, okay, and so on. The other kind of rough is rough L. It is based on the longest common subsequent or LCS between the generated text and the reference text, focusing on the sentence level fluency. So there's an algorithm, LCS algorithm. We can apply the LCS algorithm to check between the two texts from generated and reference. We have rough W. W means we have a weighted version from this L. It means we will give more importance to the longer consecutive matches. And we have rough S. Rough S means we want to measure the overlap of skip bigrams. So if you still remember, we learned about the skip gram. So we can have the skip bigram. So if the word, we have a very long word, I want to eat sushi, for example. So it means we have 1, 2, 3, 4, 5. We have 5. And if we want to check the skip, let's say skip 1. So if I skip 2, then it means, yeah, I can have, I want blank eat sushi. So there's a skip gram. If skip bigram, then it means I will check 2 skips and so on. So usually the RFS is about the overlap of the skip bigrams. So I don't explain all the variant, but let's look at the example of rough 1. Rough 1 means unigram. We want to check based on one word. So the reference summary, let's say the cat sat on the mat. So this is the reference. So after we have a long text, so we have the reference like this, and the algorithm of the text summarization produce this one. The cat is on the mat. So we want to check the unigram, which is based on the one word. The word is the cat sat on the mat, and then the generated we also have the unigram. The cat is on the mat. And we will calculate how many words are overlapped. So if you look at this one, the and the and the, cat and cat. What about set? Okay, this is not the same. This is not overlap. On and on. The and the. Mat and mat. Okay, then we have 1, 2, 3, 4, 5. So 5 of them are overlapped. So the count of overlapping unigrams is 5. The cat on the mat. We can measure the precision. The precision means the number of overlapping unigrams, which is 5, divided by the total unigrams in generated summary. Generated summary means the result from the algorithm. The result from the algorithm we have 1, 2, 3, 4, 5, 6. So there are 6 words. Among the 6 words, 5 of them are overlapping. Then the precision is 0.83. What about recall? So the recall means the number of overlapping unigrams divided by the total unigrams in the reference summary. The reference means this one. So this is the ground truth. The overlapping is 5 and there are 6. Okay, 1, 2, 3, 4, 5, 6. So 5 words among 6 are overlapping. Then the recall is 0.83. For the rough, usually we apply the F1 score. If you learn the classification, you will know about the F1 score. And this F1 score is the result from precision and recall. 2 multiplied by precision multiplied by recall divided by precision plus recall. Then you will have 2 multiplied by 0.83 multiplied by 0.83 divided by 0.83 plus 0.83. Yeah, the F1 score is about 0.83. So we can say that the rough one F1 score is 0.83. Is it good? Okay. Based on the definition, if it is nearby 1, then it is good. Now, let's take a look on the rough 2. 2 means bigram. If we have 2, we will create every 2 words. The cat. Cat set on the mat. The other is also the same. The cat is on the mat. Okay. And we will check how many of them there are overlapping. So there are 3. Okay, so you can see the cat. The cat is the same for bigram. Cat set and cat is, okay, this different. Set on is on different. On the is the same. The mat is the same. So there are 3 overlapping. So count of the overlapping unigram are 3, and again we will calculate the precision. The precision means the number of overlapping bigrams, which is 3, divided by the total. This is so. The total bigrams. Sorry, typo. Okay. This is the total diagram. This is also the total diagram. So the total diagrams in the generated summary, the total diagram is 1, 2, 3, 4, 5. Okay. We divide with 5. And the total diagrams in the reference summary for the recall, this is the reference summary. We have 1, 2, 3, 4, 5. So we divide with 5. And again, we calculate the F1 score. So the F1 score is 2 multiplied by precision multiplied by recall divided by precision plus recall. So we can get the F1 is 0.6. So the rough 2 of F1 score is 0.6. Again, we can analyze. This result is nearby 1. Yeah, it's more than 0.5. So it is high, but it's not that high. The other matrix, we call it PLEU. PLEU means building wall evaluation under study. It is primarily used in machine translation. Machine translation means we will do like translate, but applicable to any task that compares generated text to a reference. So we have generated summary and we have the reference summary. So if we want to compare those two, yeah, we can also use the BLE. It evaluates how well the n-grams or phrases of n words in the generated text match those in the reference text using a precision-based approach. The same with the RAF, the BLEU scores range from 0 until 1 or 0 until 100%. So where higher scores indicates closer match to the reference. So if it is 1, then it is close to the reference. If it is 0, then it is not matched with the reference. So there are several variants of BLEU, and usually we will do those things at the same time. So the n-gram precision. So we have the precision, what we already look at the graph. So the BLEU calculates the precision for different n-grams. You can use the unigram, you can use bigram, and etc. by measuring the proportion of n-grams in the generated text that match the reference. So the idea is similar with graph. There is another variant, we call it brevity penalty. So the BLEU includes a penalty. So this penalty is a measure to avoid favoring shorter generated text over longer ones that closely match the reference. So this penalty is applied if the generated text is shorter than the reference. If the generated text is shorter, then we give some penalty. But if it is the same, no problem. And we will also measure the geometric mean. The geometric means we will calculate the mean of the n-gram precision. The mean, just the average, from unigrams, bigrams, trigrams, and etc. usually until 4 grams. So let's see with example. Now let's make a longer text. So we have a reference text and we have a generated text. For example, the quick brown fox jumps over the lazy dog. And I have the generated text, or this is the summary. A quick brown fox jumps over the dog. Then you can do again like what we did before. If we do with the unigram, it means if we do with one word. So the quick brown fox jumps over the lazy dog. So the blue color means this is the overlapping. This is not the same, and there is no word lazy. So the number of match is 7 for unigram. What about bigram? Okay, so we have the quick brown fox jumps over the lazy dog, and you can calculate the overlapping. Okay, so this is overlapping, and this is not, and this is not. Then you can see the bigram is 5 for the overlapping, or we call it the 5 match. So we can calculate the unigram precision. The unigram precision means the number of matching unigrams is 7 among the total unigrams in the generated text. The generated text is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8, and 7 of them are matching. So we have the precision 87.5. The bigram precision means we want to check the number of matching bigram divided by the total bigram in the generated text. So the total bigram in the generated text, there are 7, and 5 of them are matched. So we have the why this one 0.8? Oh, 5 by 7, 0.71. Why there are many people? Okay, what now? 0.1714. Okay, maybe I make only 0.71. 0.71, and we can calculate the geometric mean. So the geometric mean means we want to get the unigram precision multiplied by the bigram precision, and we do the square root. So the square root of 0.875 multiplied by 0.71 and equals 0.79. So the final score, not the final score, this is the BP. BP is the brevity penalty. This is brevity penalty, BP. So the BP can be measured with this formula. X is the exponent of 1 minus the reference length divided by the generated length. So the reference length means this one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 words in the reference length, and the generated length we have 8. So if it is 1 minus 1, of course this will be 1. But because this length is different, then we have some value, which is 0.89. And when we do this one, we can calculate the PLE. So the PLE score, the total PLE score is from this one, which is 0.79 from the unigram precision and the bigram precision. And we can include the penalty. So we can include the penalty. Then the final score will be about 0.7. So we can say that the generated text captures about 70% of the key phrases in the reference text, considering both unigram and bigram overlaps. Okay, so this is the PLE. For the Meteor, okay, let's have a break. I will continue after the break.